So here we've got the circuit board out of a Lasko 5588 ceramic heater. It fell over and now is not powering on. And one lead of this polypropylene film capacitor is broken off. We're going to solder that back on and give it a test. I'm going to use hot tweezers to grab the broken piece of the lead out of the circuit board. Now we're going to use some solder wick and wick up the remaining solder there so the hole is clear, so we can stick the lead back through and reattach it. The soldering iron is set at 700 degrees Fahrenheit, and I'm using a pretty large tip to make the wicking process a lot quicker and easier. I got the lead stuck back through the circuit board. It was a little bit of a bugger, so I wasn't able to get that on video. Now we're going to go ahead and apply some solder. We're just going to keep applying solder slowly until we get a nice joint built up here. Beautiful. We're going to heat the whole thing back up here and reflow it, make sure we've got a good joint. And let's scrub this up here with some isopropyl and a Q-tip. Get the whole area cleaned up so it looks like we weren't here as much as possible. Alright, let's go test it now. Still no power, so we're going to go ahead and get the board back out and take a look at it again. We've got standby power, so let's check the power switch next. Got 5 volts there. Let's press the button and nothing. We still got 5 volts. Let's check one of these other switches here. 5 volts. Let's press the button here. There we go. And you can see that switch works. It pulls it down to 0. So we're going to replace the power switch. Going to use some flux here and a solder wick and see if we can wick this solder up. We could probably get it out with the hot air gun, but sometimes the leads on these tack switches aren't straight, so it's kind of wedged in the board, so we're going to see if we can get it out a little easier this way. Going to use a larger tip this time again, and we're just going to heat up the wick on top of the solder, and it's going to suck that right up for us on all 4 of these pins. And then we'll go ahead and apply some low melt just to make it a little bit easier, keep everything liquid while we pull that tack switch out. Going to speed this up a little bit while we do these last 3 here. Now we're going to apply some low melt solder to all 4 pins. That way we can get them all liquid at the same time easily. It really doesn't take much heat at all to get the low melt solder liquid. A lot of times you'll find it's still liquid several seconds after you're done working with it. 3rd one done there. Get this 4th one. Perfect. Now we're going to apply heat to all 4 pins and get them all liquid, and then we should be able to push the switch out. And we can push down a little bit on each pin, and then we'll pull it the rest of the way with some tweezers from the bottom. And it's out. I wasn't able to find any reference to the marking SE22 online, but just a standard 6mm by 6mm by 5mm tactile switch off Amazon is what I grabbed. We're going to go ahead and get this area all cleaned up here, and then we're going to solder that switch on here and give it a test. Squeaky clean. Let's slide the new switch in here. It fits pretty snug, so we're not going to have any trouble holding it in place while we solder. You can see there was still a little bit of flux in the holes in the circuit board that came through on the end of the pins when we pushed the switch through, but that'll just help us a little bit in the soldering process. First one done. Second one done. 3rd one done. And 4th one done. Got to come back and hit that 3rd one again real quick. And much better. Scrub this area up one more time and we'll be ready for a test.